This video segment continues the discussion about how organisms are responding to climate change. The previous segment focused on changes in precipitation and salinity. Here we examine pH. Its major points are, number one, the pH balance of the oceans has multiple effects on the biological processes within it. The balance between acids and bases in a medium has multiple effects on the biological processes within it. These effects include the conformation of biochemicals, the storage of biochemical energy, and the stability and availability of inorganic compounds. A brief review of water chemistry might be appropriate here. Hydrogen is the lightest element. The common isotope of hydrogen consists of a single negatively charged electron spinning around a nucleus of a single positively charged proton. When hydrogen ionizes and loses its electron, only the proton remains. Water, H2O, is a polar solvent. The oxygen atom O in a water molecule strongly attracts the electrons of the hydrogen atoms, H2, resulting in a net positive charge on the hydrogen atoms and a net negative charge on the oxygen. The uneven distribution of electrical charges across a water molecule fosters interactions with other water molecules and with other charged molecules. This uneven distribution also facilitates the dissociation of water into protons and hydroxyl ions. The activity of protons in a solution determines its pH, a measure of acidity or alkalinity. In precise terms, pH equals negative log base 10 alpha protons, where alpha is the activity of protons. In dilute solutions, the activity of protons is very similar to their concentration. An aqueous solution is considered neutral, neither acid nor base, when the pH equals 7. Because at this value, the concentrations of protons and hydroxyl ions are the same, 100 nanomoles per liter. Many biochemicals have electrical charges on their surface. For example, the A in DNA stand for acid, meaning that in a neutral solution, DNA molecules tend to lose protons and assume a negative charge. Proteins are constructed from linking together different amino acids. An amino acid, as the name implies, has one end that tends to lose a proton and assumes a negative charge. Less obvious is that the other end of an amino acid is a base that tends to gain protons and assumes a positive charge. These tendencies to assume positive or negative charges depend on the pH of the solution in which the biochemicals are dissolved. If the solution is acidic, the DNA and amino acids are less likely to lose a proton and are more likely to be electrically neutral. If the solution is alkaline, biochemicals are more likely to lose protons and assume a negative charge. Because opposite charges attract and like charges repel, pH-dependent changes in surface charges influence the conformation of biochemicals such as DNA and proteins. Conformation of these molecules has a large effect on their functioning. Organisms have sophisticated mechanisms to maintain cellular pH within narrow limits and prevent conformation changes that might interfere with the proper functioning of their biochemicals.